Hi viewers, let's see the simple BJT amplifier in this video lecture. So already I drawn the BJT amplifier circuit. Uh, Actually I used the voltage divided bias in this amplifier circuit. So you must know amplifier means the input weak signal amplified by the BJT. That weak signal is converted into the strong signal. So in this diagram I show the BJT amplifier with the voltage divider biasing. Okay, so this is the BJT. This R1 and R2 is the voltage divider network. This is for giving the input output biasing to the BJT. So this is biasing voltage. This R4 is a collector resistance, this R3 is emitter resistance, this is bypass capacitor, this capacitor C2 and C3 is input output coupling capacitor, this R5 resistor will act as the load. So the output is connected with channel A, input is connected with the channel B. Okay, so this is a simple amplifier circuit. I do not make the proper design with this circuit. I simply place all the resistor randomly. But one thing you must know, compare R1, R2. R2 should be 10 times R1. R3 should be minimum, R4 moderate. So this arrangement used for avoiding heat of this transistor. This resistance is called it as thermal runaway resistor. This is called it as bypassing capacitor. After switch offing this BJT, the drop across R3 will be bypassed through this capacitor to the ground. This arrangement to prevent the BJT from thermal runaway. So these two are only for biasing arrangement. This collector sometimes acted as the load resistance. This C2 and C3 called it as coupling capacitor. The purpose of this two capacitor is to separate AC and DC signal. C2 and C3 prevents the DC signal enter into the biasing. If it is prevent enter into the biasing, it's shifting the operating point of the BJT. That's why we have used C2 and C3. So I have to set 5 volt in the battery. Input source I already set 0.1 volt, 1 kilohertz frequency. So one more thing you should be remember, any amplifier circuit will not be properly perform the entire range of frequency. Certain range of frequency only the amplifier will amplify the faithful amplification. The faithful amplification means the input output signal shape do not alter. Okay, whatever may be the input signal shape, the same signal shape should get in the output also. Such kind of performance only happen in certain range of frequency. That range of frequency is called it as bandwidth of the amplifier. Okay, so the amplifier will produce almost maximum gain in certain range of frequency. After that frequency, either in lower sideband or maybe the upper sideband, the amplifier will give the distorted signal. So I am not explaining detail design performance of the circuit. In order to show the performance, I place some random components. Few things I am explained about amplifier. One more information. In BJT amplifier, input signal, output signal having 180-degree phase shift. That means if the input signal positive peak is happen, in the output signal negative peak will be uptime. Okay, let's see the performance of the circuit. See, this is the yellow line. Here the channel A I connected the output signal. So the yellow waveform is the output signal, the blue waveform is the input signal. the signal is amplified. Okay, so this is bigger in size, this is smaller in size. While I potentiate this waveform, you can see the little bit of phase difference. There is no exact 180-degree phase shift does not happen, but almost some phase difference between input and output. Already I said the exact performance of the amplification happen only in the certain range of frequency. In the input side, already I shown you here. I set 1 kilohertz. Okay, in the input side I said the frequency is 1 kilohertz. That around 1 kilohertz, if it is the center frequency of the bandwidth, then we can get the exact response. The amplitude of the output signal maximum compared with the input, and also the phase difference exactly in 180-degree at the center of the bandwidth. Otherwise, that 100% of gain, the flat response bandwidth, we can get the exact waveform. Lower sideband, upper sideband, little distortion will occur. Okay, so I am not showing you the exact design. Why? Because it will be the very lengthy process. Just I want to show how to simulate, how to connect the simple BJT amplifier I shown here. Even you have changed the biasing voltage, this battery voltage, the response will be changed. Similarly, this R1, R2 resistance and this thermal runaway resistor, if you are changing these values, we can get a different response. Okay, so once again I show you the response. You can see like this. So in order to show the phase difference, I am merging the two waveform. The blue is input waveform, yellow line is the output waveform. Now the signal is amplified. This is a simple amplifier circuit. I think little bit you can understand the circuit. In this circuit, I did not show you how to connect the circuit. Many videos I show you how to place the component and how to connect. This is little bit a big circuit. That's why I already connected the components and I show you only the response. I think this video also useful for you. You can learn something about the BJT amplifier. Anyhow, thanks for watching. Like this video, subscribe and share to your friends. Thanks for watching once again.